Good afternoon, everyone. I'm Rohit, and I'm thrilled to be here with all of you at Target Multiply. Before I start, I wanted to ask a question about your shopping habits. Can I get a show of hands in terms of how many of you, when you are out shopping in a store, like to check out the bargains in the discount section? Oh, wow. My wife often jokes that if she thinks I'm lost while shopping, I would definitely be there in the clearance section. I love bargains. So if the last couple of years have taught us anything, retailers have done really well when focused on three main basics. One, by providing an exciting assortment of products. Two, by providing a great shopping experience. And three, by offering affordable pricing. Markdowns, which is about lowering the price on an item, also I'll interchangeably use clearance, is getting that discounted pricing right. And I want to thank Dr. Radhika for talking about this problem on a very high level earlier and why it is important. Clearance is a big business driver for Target too. It helps to drive guests into our stores, and it also offers a big opportunity to drive profitability. Billions of dollars worth of inventory go into clearance every year. And even though these items are being sold at a discount, our guests get the best value. Target also makes a profit. It's a win-win. Before we look at how we are in the process of solving this problem, let us take a step back to understand the end-of-season planning process a bit more. For a clearance program to be effective, timing needs to be right. Every product has a life cycle. Pink teddy bears do not sell a lot once Valentine's Day is over. Students love to stock up on school supplies very early on in the semester. And I don't think many of you are buying winter clothes after an April or May as you step into spring and summer. So enabling markdowns at the right moments can make a huge difference. If you pay attention to the graph behind me, I would love to talk about what we call the product life cycle. So whenever a new item reaches our shelf, sales normally increase for a while, and then reaches an inflection point, and after that, as you can see on the graph, the demand for that item just drops. And this is where clearance kicks in. We begin to sell the item at discount. There are two approaches we can take from here on. The first is to offer a very high or steep discount. Naturally, this will help to get rid of the inventory out of our stores and our distribution centers very fast. The risk is that you will make a lower profit on those items. Great for the guests, not so great for a business. The second approach is to offer a lower discount. That increases profit, but it could keep the items on our store shelves or back in our distribution centers for a longer time, increasing our operational costs. There's also a risk that a lot of these items may eventually never sell out and go into what we call salvage. Salvage provides virtually no financial gain to Target. So, also not a great option. So as a retailer, we are always looking for that perfect balance between these two approaches. That is a yellow line that you see behind me in the middle. In the past, we did this manually through a rule-based decision-making process. It was time-consuming, especially when you consider the millions of item location combinations that go into clearance every year. And that's when we built an AI solution that would help us to profitably manage the end-of-season planning process. Why is this an optimization problem? At the heart of it, we produce optimal markdown schedules for thousands of clearance programs that run in our stores every year. And we are looking at maximizing profitability against the backdrop of complex business constraints that keep coming at us every year. I think we talked about supply chain challenges over the last 2 years, and there's a lot more with every product category that we face. Let's take a deeper look into this optimization problem. Here, We're taking a sample clearance program of one item at one location for going through a clearance period of 8 weeks. And let's look at the vast amount of decision states that have to be considered. At the first week, assuming there are 5 markdown options, there are 5 decision states that have to be considered. By the time we reach the 8th week of clearance, that just balloons up exponentially to about 5 to the power 8. That's 400,000 decision states that have to be passed. Now multiply that by about 200,000 unique items that goes through clearance every year. Now multiply that value by 2,000 store locations that we sell these unique items at. At this point, we are talking about billions of decision states through which the team has to pass to find that winning markdown schedule. Obviously, large retailers need a highly scalable AI solution to solve this problem. So how did we make this work for us? The brains behind our markdown optimization is what we call the decision module. There are 2 key decisions that need to be taken within this module. The first is to determine the baseline demand during the clearance week. An initial challenge that we run into, and I'm sure all of you practitioners would see that there is sparsity of data, especially when we're looking at sales across different locations for an item. So we had to determine the baseline demand for each item at a rolled-up store cluster level. How did we get to these clusters? So we had to use a heuristic of an inventory to sales ratio. From that, we determined that there are ideally 6 store clusters we want to look at. And then we map every item to these 6 unique store clusters. And for each of these store clusters, we found the deseasonalized sales quantity for 12 weeks leading up to the clearance window. We then apply a damped trend exponential smoothing technique to predict what would be the demand for the item during that clearance program week. The second key decision is to determine price elasticities at an item level. As an input, we use historical data from about 4 years, including retail price, markdown percentages, and sales quantity at an item cluster level. This data set is then enriched with information around holidays and events like Easter or Valentine's Day and a lot of other additional holidays. We then determine the price elasticities using a log-log mixed effects model. Once we have this, we combine the forecasted baseline demand from the first decision with the price elasticities to get to the demand forecast for every item, for every store cluster, for every single markdown percentage. And this is an input to the next module, which is the optimization module. Let's look at what goes into this. So I talked about the demand forecast from the decision module. Apart from that, we also have price and inventory that goes as an input into this. This is posed as a multi-objective linear programming function whose objective is to maximize our profitability while minimizing salvage, as I called out earlier. And we operate under various business constraints driven by category-level decisions, as well as store workload decisions. We then sum up the demand across an item for every clearance program week that it's running. And then it's bound by, like I said, a lot of constraints. One of them that you see in the mathematical formulation is making sure that we are looking at selling the inventory that we actually have for the item for the locations that we have predicted the demand. Finally, the solution or the output, which is the winning markdown schedule for the item for each store location, is sent to our business partner teams who activate this in all the locations where those items are sold. And this process is repeated thousands of times for every clearance program that we run every week through the year. Now, there are multiple ways in which our partnership with the pricing team has impacted Target's profitability overall. First is that as we optimize the markdown schedules, we are able to maximize the revenue as we see. over time, by also ensuring that we are selling our inventory optimally through our network. We minimize the salvage that these items would have otherwise gone into. Last but not the least, we're also ensuring that we create operational efficiencies in our store by ensuring that our store team members' manual labor that otherwise goes into ticketing those items in our shelves is reduced. Our work in this space has been a journey. We started by building a really strong business relationship with our business teams, along with other partners from platform engineering, data engineering, and so on. We made sure that we identified the problem as a team. We made sure we are identifying what are those business constraints. And then we started very simple, with simple models. Why simple? Because then they are explainable. When your inputs, your outputs, and the maths that goes behind your early algorithms are easy to explain to your business partners, that starts building trust. And as we started building that trust, we were able to then scale with proof of concepts, with multiple A/B tests that we did in various markets. And this continued to build trust with our partners as they started seeing the business value that the solution was realizing. Along the way, we also built a model trust framework. Like I said, building trust was always at the heart of the solution. The model trust framework, including backtesting with historical data, we also continue to enrich the explainability with additional features as part of this framework. We've been using this now for multiple years. And today, the decision model has started to become embedded within operational systems that the business user sees. This has enabled a lot of automated decision making, which now keeps the data science team in the background. As we continue our tests and as we continue to learn from how our different clearance programs are operating in our markets and feedback from our business, those are awesome feedback loops for our algorithm to constantly iterate and just keep getting better and better. However, we have much ground to cover. What you see here is a fancy motorbike. We would love for this to be someday an autonomous self-driving car. That is our vision, our dream. And I now welcome my partner from engineering, Abhijit, to talk about how we are scaling this solution on our platforms. Abhijit.
Thank you, Rohit. Hi, everyone. My name is Abhijit Mangalgiri, and I lead technology for pricing at Target. Now, Rohit just explained why clearance pricing is an optimization problem. In the next few minutes, I want to talk about how we scale that solution. But before we get into that, let's understand why even this is a problem of scale and what are the dimensions of it. Now let's consider about 20 apparel items are going out of season to make way for the new assortment to come into the stores. Now at Target, we put them on clearance. These items are grouped in what we call as a clearance program. Now these 20 items going into clearance across 2,000 Target stores. That makes it 40,000 independent items. And the goal of the problem is to really compute the most profitable markdown schedule. We have to then figure out how we basically compute all the possible permutations of mathematical possibilities of discounts and then arrive at the winning markdown schedule. Now, when we started this effort, we realized that this is not a problem that can be solved by just doing a one-size-fits-all approach, right? And so if we have to really arrive at the profitable discount schedules, we had to compute multiple forecasts and multiple discount schedules to really arrive at winning schedule. Now, When we did that, we realized that that resulted in about 6 million forecasts. Now we saw 20 items going into clearance across 2,000 target stores with 40,000 independent items resulted at 6 million forecasts, all in the context of one clearance program. And so now if we explore this from one single clearance program to thousands of clearance programs at a given point in time, you can imagine how many pricing decisions and forecasts we'll have to compute. Now, the second dimension, apart from scale, is the forecast accuracy. Given that billions of dollars worth inventory goes through this system, it is important for us to, design the forecast with accuracy. Now, every single basis point improvement or degradation that happens in forecast accuracy can result in millions of dollars of impact to target. And hence, the goal of the system is not just to scale, but to drive accuracy at scale. Earlier in the day, Brad talked about how we are integrating ML models with our applications. And that forced us to have a distinct clarity on what's analytical workload versus what is the operational workload. Now, most ML models are initially created to run on analytical runtime, which is predominantly our Hadoop ecosystem, which we call Big Red. While the baseline architecture, and you see what you see in the diagram, is basically a classic ML model workflow. Now, the baseline architecture, though it worked functionally well, it failed short of delivering performance and throughput. Now, it took 48 hours to actually process our 100% of the workload, and the long cycles of runtime was not just an issue of scale, but also about the usability. Now, imagine a user who's actually keying in clearance programs in a planning application. When they hit the forecast button, they would expect the forecast to come back in minutes, if not instantaneously. And so we re-architected the solution. You can see the capabilities like exploratory data analysis, model training, and trust are modeled on analytical runtime. Whereas the capabilities like scoring, optimization, and anomaly detection are designed as event-driven pipelines. Now, every stage of the scoring pipeline is abstracted as a Kafka consumer. And that leverages all our science capabilities that are exposed as idempotent, stateless APIs that optimize the pricing decisions and compute forecasts. So, with this new architecture, we were able to achieve almost 20 times improvement in our performance and 30 times improvement in our throughput. Now, any forecasting capability requires access to historical data like price, sales, inventory, etc., which is typically present in an analytical store. And an operational system requires to access this data in real time. So, in order to make this data available with low latency, we used Elasticsearch as our forward cache. But we also needed to have equally efficient clients to be able to access that data. And so we chose Kotlin coroutines, which are lightweight and memory efficient over the base threading model. Now, ML models are not perfect. They do generate erroneous estimates. So when you run forecasting and optimization for millions of item locations, detecting outliers and anomalies is a very critical component. But the most difficult part about anomaly detection is its accuracy. If your thresholds are too wide and tolerant, you will miss out on true anomalies. If they are narrow, you will have a lot of false positives. So it is important to measure false positives, false negative rates, and iteratively tune the anomalies. Some lessons from the trenches. Now, building the model is one thing, but taking it to production and building trust with users is a lot harder. It is time consuming, it requires a lot of experimentation and iterations. And our longer term success will depend on the model iteration speed. Ideally, the time to refresh a model should be in hours, not in days. Secondly, trust is not just a word. It is a statistical measure of the risk for business to evaluate. But how do you build that trust? You need a well-established model trust framework that effectively simulates your model on historical data. And then third, in any opportunity space, especially during the early stages where the boundaries are fuzzy, we tend to have a lot of hypotheses in the form of opinions. So deciding what not to do becomes as important as deciding what to do, which is exactly why we invest in an effort called size of the prize, even before we actually begin to solve the problem. Now, this effort looks at the historical data and then validates or evaluates the hypothesis. As I come to an end, I want to leave you all with one thought. A solution like this can come to life only through power of co-creation that brings the best out of people across various disciplines. Thank you.